This is our video regarding preparation of water insoluble salt. So these are the different steps that shows how water insoluble salt is prepared. So in first step, we have two transparent solutions, two aqueous solutions, and these aqueous solutions are mixed together to produce insoluble salt by precipitation reaction. Then what happened? These precipitates are separated by filtration process. Here filtration is being done. Then after filtration, we wash the precipitate and we get these pure precipitates of our required compound. We will see in detail in other slides. Now see this is one of the reaction. What's going on? See, when it is going, this is one of the solution, it is another solution. When they combine together, see again, see, both of these are transparent solutions. Both of these are aqueous solutions. There is no solid, you can't see any solid here. But now, see, the yellow solid is obtained by the reaction between these two. This insoluble material is obtained when when you get an insoluble material, insoluble salt, by mixing two aqueous solutions, by mixing the aqueous solutions of two salts. Aqueous solution means definitely those salts uh, were or are soluble in water. That's why they are making aqueous solution. So sometimes they combine together to produce insoluble material, insoluble ionic solid, that is called precipitate. So what are precipitates and what is the precipitation reaction? See, it is a typical double displacement reaction. Double displacement. What is mean by double displacement? I will show in the next slide. Which occurs when cations and anions in an aqueous solution combine to form an insoluble ionic solid, and that insoluble ionic solid is called precipitate. So the reaction that is on right side in video, some ions definitely would be there and some ions would be there. So one of the ion from here and one of the ion from this test tube, they combine together to produce this insoluble ionic compound that is yellow in color. We will see in detail in our next slides. So first see what is precipitation reaction and what are precipitates. These are the insoluble ionic compounds which are formed when cations and anions combine on mixing two aqueous solutions, as you have seen here in the video. See again. So on mixing, we got these yellow precipitates. Precipitates means now you know yellow insoluble compound. Now see, what is a double displacement reaction? It is a type of reaction in which two reactants exchange their partner ions to form two new compounds. Okay, now see, for example, A and B were combined together and C and D were combined together, and you have separated them. So what happened? They have exchanged their partners, and as a as a result, you got CB and AD. And this is one of the example of the double displacement reaction. For example, here potassium iodide. The video that you have seen in previous slide is the reaction between potassium iodide and lead nitrate. Potassium iodide and lead nitrate are soluble in water. That's why we have written here aqueous. We have taken the solution. One solution was in test tube, another was in the dropper. So we obtain the solid ionic compound that is lead iodide and potassium nitrate. It was also in aqueous form. So we got the yellow PPT you have seen. Now, another skill that you should learn here is how to write the ionic equation. If it is written in aqueous, so it means potassium ions and iodide ions both are separated in the solution. I will show it again in the next slide. And lead nitrate is also aqueous. It means lead ion and nitrate ions are separated together. They remain ionized in water. But what happens when both of these solutions are mixed together? On mixing, we got lead iodide as solid, insoluble particle, while potassium nitrate remain in the solution. So if you see, the state of the potassium ion on right and left side of the equation is same. So we can cancel these out. Again, the nitrate ions are in the same state on both the side of the equation. So we can cancel these also. So what is remaining? Remaining is lead ion. So the potassium and nitrate ions are called spectator ions because their states are not changing during the reaction. That's why we do not write in ionic equation. So the final ionic equation contains only the lead ions from here and iodide ions from here, and they combine to form lead iodide as yellow precipitate. So this is the ionic equation. Now see, the same reaction with potassium iodide and lead iodide is depicted here. So you can see here there are two aqueous solutions, and fortunately both of these solutions are colorless. So this is the lead nitrate and this is potassium iodide. What happens when we mix them together? We obtain this yellow precipitate of lead iodide. This is lead iodide, and potassium and nitrate ions were already in aqueous form, in separated form, in ionized form, and they're still in ionized form. So in ionic equation, we don't write these ions, but in complete equation, we need it. So the reaction is this that we have already seen in the previous slide. Potassium iodide combined with lead nitrate to produce lead iodide and potassium nitrate. Now, with this figure, you can understand that aqueous means they are in ionized form. If an ionic compound is in aqueous form, then they are in this way. Next, yellow PPT. Now see, this is another reaction, another precipitation reaction. One compound here in this solution, aqueous solution, another in this beaker, it is also an aqueous solution. What are these? This contains sodium ions and sulfate ions. So actually it is sodium sulfate and it is barium nitrate. So it contains barium ions and nitrate ions as they are soluble ionic compounds. So they are in the form of their ions. See what happened again. See again. When we mix them together, white precipitates obtained, white insoluble component is obtained. So actually what happened inside this test tube? Previously, it was only sodium and sulfate ions in water, and it has only barium and nitrate ions. But what happens? White precipitates are obtained. And here, now, barium sulfate is combined. These white precipitates are of barium sulfate, but sodium and nitrate ions are separated. See the chemical equation. Sodium sulfate combined with barium nitrate aqueous solution. When both of these aqueous solutions are mixed together, they produce an insoluble salt. Barium sulfate, it is an insoluble salt, and sodium nitrate aqueous, so its ions remain there. So white precipitate of barium sulfate is obtained. Now when you are going to write ionic equation, the rule is same. That what to do? We will write all the ions together. It should be 2 minus. I think I forgot this. See, so what happened? These solid white precipitates are obtained, and we can cancel out sodium ions because they are not changing in state. They are spectator ions. Nitrate ions are also spectator ions. So what is remaining? Only the barium and sulfate. So see, we write barium and sulfate here, and then we obtain these white precipitates. What happens? One of the solution is here and another is here. It contains barium nitrate and it contains sodium sulfate. See what happens. White precipitates are being obtained as shown in this figure. So see the complete video. Slide. Yes, here. So you have already seen these equations and how to write the ionic equation for such reactions. You may see this. And here you have seen the video. See it again. Okay, now see how these reactions are occurring within the solution. I'm giving you an example of reaction between sodium iodide and silver nitrate to get the precipitates of the silver iodide. See, it is one of the solution where sodium iodide is there, and here the silver nitrate is here. By mixing, what happens? Both of the uh, compounds are in the same solution, so they are in ionized form, and they will collide with other molecules as well as these ions. So they may collide with the opposite ions which are insoluble. For example, silver and iodide, when they collide, they produce this insoluble salt that settle down or that remain insoluble in the solution. So while the other ions, which are the sodium ions and nitrate ions, remain as it is as they were previously in their own solutions. So these are considered spectator ions. See the equation here, sodium iodide in aqueous state combined with sodium nitrate. and they produces silver iodide and sodium nitrate. So if you want to write an ionic equation, then you will ignore sodium and nitrate. So what is remaining? It is iodide and silver. So silver ions in aqueous state combine with iodide ions in aqueous state and they produces insoluble sodium iodide. Now question is that why they are insoluble and why are these soluble? You will get this answer in your A level because or intermediate or higher studies, because the detail of these things, these phenomena is not in our syllabus at this level. Properties of precipitation. The reactants should be in aqueous state or medium in an ionic state. Okay. Aqueous state means a medium in an ionic state where they are in the form of their separate ions. When they would be separate, then they can combine with others. It takes place between aqueous ions of the reactant present in the solution which form products. You have seen several reactions in this video. One of the product must be insoluble. Definitely, you are to get precipitates. Why this is called precipitation reaction? Because when two aqueous solutions combine together, they produces an insoluble ionic salt, and that insoluble ionic salt is called precipitate. So which separate as precipitates. These are also called ionic reactions because exchange of ions occurs during the reaction. A type of double displacement reaction that we have seen. We can determine the presence of particular ions present in the sample. This is an additional approach that if you want to see whether the sulfate ions are there in a solution, then you can check it by using any water soluble compound of barium, for example, barium nitrate. And you can see my other videos for detection of ions in this regard. So now see one thing. Now we are going to our topic regarding 1 minute. Now see here we have discussed the preparation of lead iodide. Previously we have seen the video that how lead iodide is obtained by combining two solutions, one containing iodide ion and another containing lead ion. So these are the two solutions. It contains lead nitrate, that is water soluble, and lead ions are there. And this is sodium iodide where, or the potassium iodide where the iodide ion is present. So we can check any water soluble iodide salt. So these are the two aqueous solutions. You have seen in the video that we got yellow precipitates of lead iodide. Then what we do, we will we do filtration, and in filtration we need a funnel. A conical flask is better to use, and this filter paper. We are making the cone of this filter paper. I will show in the next slide a video regarding all these steps. And then what we do, we pour all this mixture. Why I'm telling it mixture? Because it contains lead iodide, water, and water soluble compound For example, potassium ions and nitrate ions. So potassium nitrate is also there. Now see, we have poured it into the filter paper. So on filter paper, insoluble material remains over there, while whatever is coming down, that is called filtrate. That in technical language, in chemical language, it is filtrate that comes out of the filter paper. So it contains potassium nitrate and water. Then we wash it. Okay, when all the liquid pass through this, then we wash the precipitate over there because it may contain some potassium and nitrate ions, and we want to get the pure lead iodide salt. So that's why washing is important. So after washing, we get this result. Okay, now see the video. The stepwise process is shown here. These are the two solutions we are mixing together. See, yellow precipitates are obtained. Now, next we are making cone of the filter paper. See again, this is the first turn. Then it is the second fold. Now you can see there are 4 layers. Sorry, see again. First fold, second fold, and there are 4 layers. 1, 2, and 2 are here. So we will put 3 aside, 1 another side. So a cone of filter paper is obtained. We put it there. And after pouring, we can separate these yellow precipitates. It takes little time to go down. And see, the transparent solution is coming. Yellow precipitates remain over there. This is the beauty of filtration. So the filtrate that is coming here, this filtrate contains water, along with potassium and nitrate ions, but the lead and iodide ions remain there. We have different techniques for rapid filtration that you will learn in your higher classes. And then after this, when filtration is completed, then we wash it with distilled water, and then we will dry the precipitates to get pure solid, pure precipitates. And at that time, they will not uh, precipitate, because precipitates, the term precipitate is used in the solution when two aqueous solutions are combined together. and we get insoluble part. That insoluble part is precipitate. But when you will get it in dry form, then they are called solid. So we can get the lead iodide in solid form, as we have seen in our previous slide. Here you can see here. So this is the way how to get the insoluble salts in our laboratory. So you must have two aqueous solution containing the opposite ions which are present in the precipitates in the required salt. In the same way, you can get the barium sulfate, you can get silver iodide, silver chloride. These all are insoluble salts. So whatever the insoluble salt is there, just you need the appropriate aqueous solutions, and remaining steps are the same as you have seen here. So inshallah, we will meet with another video next time.